Okay, let's continue our example that we started last session number 1. So the example is the following about the capacitors. So let me just draw again this. So this is C1. I will call it C1. It's 2 microfarad. Let me just, before doing this, okay, this is okay, and then there's another one here, and there is another one, okay, and so yeah, so there is another one. This is point B, and this is point A, and the potential difference VAB is equal to 20 volt, and here we have 2 microfarad, which I will call C1. This is what I called it. This is how I called it in the previous exercise. C3. This is C2. Sorry, C2, and this is C3, which is 4 microfarad. This is C4, which is 4 microfarad, and this is 2 microfarad, and I will call it C5, and this is C6. Okay, C6. It is 3 microfarad. So we have demonstrated in previously that the equivalent circuit of this, the equivalent capacitor of across AB is equal to 3 microfarad. Okay, now the question here, the next question will be, what is the potential difference across each capacitor? Potential difference across each capacitor of those capacitors, so the individual capacitor across each capacitor. Okay, this is what we are going to solve. Now, let me define the following. I will define V1 as the potential difference across C1, V2, potential difference across C2, V3, V4, V4, V5, and of course V6. Now, the first thing that we need to do is to remember that the potential differences add. So we'll write down the equations of the potential difference. So the first equation will be that the V1 plus V2 is equal to 20 volt, because if you look at this, V1 plus V2, they form the potential difference across A and B. Okay, so I will just delete it. So this is the first equation. Also, if you look at V3 plus V4, okay, plus V6, they are also equal to 20 volt. So if you go from here, from this point until this point, so V3 plus V4 plus V6, they are also equal to 20 volt. And we know that the potential difference across potential difference on V5 is equal to the potential difference of V1, because those branches, the C1 branch is parallel to the C5 branch. So V5 is equal to V1, and also V2 is equal to V6. Okay, those are the equations that we have. So V2, this one, V2 is equal to V6 because they have the same point where they, the same junction, and it's the same potential. Okay. Then we also know that in each capacitor, the capacitance is equal to the charge through this capacitor divided by potential difference in this across this capacitor. So we know that, for example, the total charge, I will call it total charge. Total charge is the charge that is going from here. I will call it total charge. The total charge will be split in something that I will call Q1 and Q3 and Q5. Okay, it's like the current. Actually, it's a flow of current. So QT is equal to Q1 plus Q3 plus Q5. QT, the total charge will be split at Q1 plus Q3 plus Q5. Well, I know from this equation that charge is equal to C times V, to the capacitance times the voltage. So QT is what? QT is the equivalent capacitance times the potential difference across B, which is 20 volt, is equal to Q1. Q1 is C1 times potential difference V1 plus Q3 is the potential difference, the capacitance C3 times the potential difference V3 plus C5 V5, right? We can also see that because of this equation, so this, actually this one, because of this equation, that the total charge, this charge, is equal also to the total charge in Q2 plus total charge of Q6. In fact, this is coming from here. So this is the charge Q2, and this is the charge coming from Q6, and they will go into the total charge. So the total charge on Q2 plus total charge on Q6 is equal to the total charge QT. Okay, so that's why they are equal. And what we know, we also know that V2 is equal to V6 and C2 is equal to C6. Okay, from here, and C2 and C6, they are both 3 microfarad. So this means that C equivalent VAB is equal 2 times 2 V2 or 2 times C6 V6. Now, let's take one of them. This means that C2 V2 is equal C equivalent VAB divided by 2. I can also delete this, and this will give me C2. Okay, so this gives me that V2 is equal to the C equivalent is 3 microfarad, divided by 2 times C2, which is 6 microfarad, and then times 20 volt, because VAB is 20 volt. So here I can see that V2 is equal to 10 volt. So V2 is equal to 10 volt, and I know that V6 is also equal to V2. So V6 is equal to 10 volt. Okay. So then we know that from those equations, V1 plus V2 is equal to 10 volt. V1 plus V2 is equal to 20 volt, means that V1 is equal to 10 volt because V2 is also equal to 10 volt. Now let's look to this equation. V3 plus V4 plus V6 is equal to, so V3 plus V4 plus V6 is equal to 20 volt. Okay, this means that V3 plus V4 is equal to 10 volt, and since V3 and V4, they have the same charge and the same capacitance, this means they have the same potential. So this means V3 is equal to V4, so 2V3 is equal to 10 volt means that V3 is equal to V4 is equal to 5 volt. So here are the sum or the summary of our potential difference. So here, if you look at this, so what will happen here is that this one will be 10 volt, 5 volt, 5 volt, 10 volt, 10 volt, and 10 volt. And you can see the V5 is equal to V3 plus V4, which is 10 volt, and it is equal to 10 volt with a V1, which is 10 volt. V1 plus V2 is 20 volt, which is the total VAB, and V2 is equal to V6, which are, both of them are 20 volt. So this is for now, and I will try to do more exercises on this in the next session.